Okay, so I don't think I've ever been cut off in the middle of a video. That was kind of interesting. But so anyway, we were talking about this. We had already discovered that one angle pair with D would be angle B. Then we started looking at this line right here, and we said that the angle pair that would make a linear pair with D here would be angle A. And so we could say B or A would form a linear pair with angle D. Alright, that is it for the vocabulary words. There's two little tiny sections of notes, one about angle addition and one about angle bisecting. So we're going to look at those now. Alright, so angle addition is just like segment addition. If you have two segments and you add them together, then their length is their sum of their lengths. That's the same thing with an angle. If you have two angles and you add them together, they make this whole angle. So in this case, we could say that angle AOB plus angle BOC equals angle AOC, the entire thing. So now we're going to look at a basic example of this. At least I think we are. Alright, so we have, this is just like with segments, piece plus piece equals whole. Alright, so now we're going to look at a basic example. This one says that the measure of angle QRS is 123 degrees. So QRS, that's this whole thing. Alright, so QRS, this entire thing is 123 degrees. And it wants us to find the measure of TRS. Well, if the whole thing is 123 and this little piece here is 40, we can find out how much is left over by subtracting. So if we take 123 degrees and we subtract the 40 degrees that are over here, we would get 83 degrees, which is what has to be left over for TRS. So angle TRS is equal to 80, oops, not 80, it's 83. 83 degrees. Alright, so last one we're going to look at angle midpoint or angle bisector. I don't know where I got the angle midpoint from. Alright, so given that ray KM bisects angle LKJ. So if this ray bisects this angle, it cuts it into two equal pieces, which means that this angle, LKM, is going to be equal to this angle, MKJ, which is what this says right here. And so then you're going to see piece is equal to piece. Piece equals piece, which is exactly what we did with segment midpoints yesterday. Alright, so now we're going to do a basic example of this. I don't want the highlighter. Okay. It says that angle LKJ, the whole thing, is 74 degrees. And it wants us to find the measure of MKJ. So we only want to know this piece of it. Well, we know that this cuts it in half. So these two pieces are the same. So if this cuts this whole thing in half, if I take 74 and I divide it into two equal pieces, I think I get 37. Yeah, 37 degrees. And so this is how much each small piece has to be. This piece has to be 37 degrees, and this piece has to be 37 degrees to make the whole thing 74. So the measure of angle MKJ is equal to 37 degrees. Alright, so now we're going to move into the class examples and the student examples. There are 4 class examples and I believe 3 student examples. Alright, so class example number 1. It says that angle BAD is 41 degrees. So I'm going to label that. Angle BAD. This angle right here is 41 degrees. And then it says angle DAC is 64 degrees. So angle DAC, that's the whole thing. This whole thing is 64 degrees. And so it wants us to find the measure of angle CAB. It wants to know this little piece right here. Well, if we know that the whole thing is 64, and we know that this little piece right here is 41, we can find what's left over by subtraction. So 64 minus 41 degrees equals, is it 23? Yep, 23 degrees. And so the measure of angle CAB is 23 degrees. Let's try another one. This says the supplement of an angle is 41. What is the measure of the angle? So in order to answer this question, we have to know what a supplement is. So supplement means that two angles add up to 180 degrees. So the supplement of an angle is 41. What is the measure of the angle? So we need to know what the other piece is. So if we take 180 and we subtract 41, we'll get what's left over, which is 139 degrees, which is the answer to this question. All right, let's try another one. And so as with segments, these get harder. So the first two that we've looked at have been all numbers. This next one, I believe, is going to be, variables and solving equations. So this says to find the value of x. Well, we have to know how these two angles are related, because we have to be able to set up an equation in order to find the value of x. Well, I can see that these two angles are directly across from each other. And when you have two angles that are directly across from each other, you know that they are vertical angles. And vertical angles are always congruent, which means that this is equal to this. So I can set up this equation. I can say that 3x minus 5 is equal to x plus 27. And now I can use this equation to figure out what x is, which is what the question's asking. Find the value of x. So I don't have any like terms on this side. I don't have any like terms on this side. So I'm going to start with the smaller variable term, which is this one. So I'm going to get rid of a positive 1x by subtracting x from both sides. So whenever I subtract x from both sides, this goes away. I'm left with 27 over here. And on this side, I have 3x minus 1x, which is 2x. And then I've got this minus 5 here. Alright, so then I can add 5 to both sides. Makes this go away. I get that 2x is equal to 27 plus 5 is 32. And then I can divide by 2 on both sides and get that x is equal to 16. And they said find the value of x. We found the value of x. So we're done with that example. Alright, let's try another one. Example number 4. This says name an angle that is complementary to angle FEB. So angle FEB is this angle right here. And it says name an angle that's complementary to it. Well, we need to know what complementary means. Complementary means two angles that add up to 90 degrees. So I can see this corner right here, which says that CEB, this whole angle, is 90 degrees. So what angle makes up that 90-degree angle with angle FEB? Well, the only angle that does that is this angle right here, CEF. So angle CEF is complementary to angle FEB. Together, they make 90 degrees. What's another way I could have named this angle? Instead of naming it CEF, what else could I have named it? Well, I could have named it angle FEC, because I could have started here, FEC. I could not name this angle E, because then I could be referring to this angle, to this angle, to this angle, to this angle, or to this angle. So when your vertex point is shared by a bunch of different angles, you have to use 3 letters to name your angle. All right, let's move on to student examples. All right, so here's the first student example. Go ahead and pause the video, try this example on your own, and when you're ready, you can hit play and you can check your answer against mine. All right, it says that segment BD, that's this segment here, bisects angle ABC. That means it cuts it into 2 equal parts. That means that this piece is equal to this piece. And then this says find the measure of angle ABC. So we're going to be looking for the measure of this whole angle, ABC. And they give us that ABD, this piece right here, is 8x minus 4. 8x minus 4. And they tell us that DBC, this piece right here, is 4x plus 20. Alright, so we need to somehow solve an equation so that we can get a value for x. And then once we have a value for x, we can plug it in, and then we can solve for what these angles are and figure out what angle ABC is. So the equation that I see that we can use, because we know that this piece is equal to this piece, we can say that these two things are equal to each other. So we can say that 8x, oops, that should be minus. Let's see if I have an eraser up here. I do. Look at that. Okay. 8x minus 4 needs to equal 4x plus 20. And now I can solve this equation. Alright, so there's no like terms on this side, there's no like terms on this side, so I'm going to start with my smaller variable term, which is 4x. So I'm going to subtract 4x from both sides, makes this go away. I'm going to be left with 20 over here, and over here, 8x minus 4x is 4x, and this minus 4 can come straight down. Alright, so I moved all the variables over to one side. Let's move all the numbers over to the other side. So the opposite of minus 4 would be plus 4. Add 4 to both sides. Makes that go away. Get that 4x is equal to, and 20 plus 4 is 24. And then divide by 4 on both sides. And get that x is equal to 6. Now this is not the answer to the question. If this were a multiple choice question, I would make sure this was one of the answer choices. And some of you will pick it because you're not going to finish the question. The question says find the measure of angle ABC. So I'm going to switch colors and we're going to do that. Alright, so we're going to find the measure of angle ABC. In order to do that, I'm going to take the 6 and I'm going to plug it back in up here. So if I do 8 times 6 minus 4. 8 times 6 is 48, and 48 minus 4 is 44. Okay, and then I can do the same thing here. I can plug the 6 in right there. 4 times 6 plus 20. Well, 4 times 6 is 24, and 24 plus 20 is 44. Now that's weird. These two are the same. Should they be? Well, yes, they should be, because it says that this segment bisects that angle, ABC. So these two pieces should be the same. So the fact that we got the same number for both of them is a very good sign. All right, and so now to find the measure of angle ABC, ABC is these two added together. So 44 plus 44 is 88. So we can say the measure of angle ABC is equal to 88 degrees. Alright, I'm going to go ahead and stop this video here, and then in the next video we'll do the last two student examples.